most valuable professional. He is a consultant for Power Platform and Azure Cloud. Mr. Selvan has an experience over 15 years in software application development and architecture and worked in various software application and languages like C, Hash, ASP.NET, React.js, jQuery, TypeScript, and big data analysis. So before the webinar start, I would request audience to feel free to send us your questions. We would be happy to answer them towards the end of the webinar. The webinar is being recorded and the link of the webinar and slides will be available after the presentation is over. So without further ado, I would like to hand it over to Mr. Selvan. Over to you, sir.
Thank you, Santosh, and thank you, Nagaraj. Today's session, I will discuss more about the fundamentals of the blockchain. Some of them might have learned about it or might have experience on blockchain as well. So in my session, in this, I would explain you some of the basics which you can start from on how to do with the blockchain and technology towards the blockchain. This is the rough idea or the topics which I would cover in an hour session. First is about myself. I just give you intro about myself so that in future, if you have any questions, you can just drop me or tweet me, then I can try to answer you even after this session. And later I would explain what is blockchain and how it works, the concepts behind the blockchain, and also the frameworks currently being used in the market for the development of the blockchain, or how it is widely used in the market technically. And finally, I would just give some brief about the Ethereum basics, because there are several levels of blockchain which is in the market. One of them is the Ethereum. So probably I would just give a basics about the Ethereum, so you can move on to the other platform if you're looking for. And finally, what is that blockchain as a service? And current latest technologies, some of the providers, the cloud providers like the IBM, Microsoft, and other cloud providers, they started blockchain as a service, as a PaaS service, which is the platform as a service. You can just readily start using your blockchain in your platform or in your application. So this is about myself. I'm Microsoft Most Valuable Professional, which means that I don't work in Microsoft, but it is an award given by Microsoft for contributing to a specific technology. Previously, I was doing blockchain. Now this year, I've been moving into the development for Office, which includes the blockchain as well, but blockchain is slightly less. This is my blog. I blog more about this Office development nowadays. This is my tweet. You can tweet me any questions later if you want. And finally, I have my own YouTube channel as well for some of the contributions which I'm doing. Okay, so I think as students from the technology as well, information and technology, you guys should have at least heard about the blockchain technology, and you should have some basics about the blockchain technology. What I would do is I would just brief about some of the core keywords or the concepts which you would start hearing often in your blockchain. The first one is the very key concept of the blockchain, why it becomes more famous and why it has been widely adopted by financial institute, especially the financial institute, is that it's a kind of a digital ledger which is decentralized. The keyword you would often hear about blockchain is that DLT, which is a decentralized ledger technology. And it is a digital ledger, which means that everything is kind of online and it goes into the cloud system. And it is incorruptible, which means that it is very, very difficult to corrupt any blockchain which is entered into the transaction. So later we would discuss how this can be achieved. And it is a continuous growing list of records, which means any transaction which is happening will be recorded as a chain of blocks, which is kind of indefinite. It will keep on adding into the blocks, into the network, peer-to-peer network. So later I would explain how it happens. And finally, it is a kind of a secured cryptography-wise encrypted transaction arranged in a block and set it into the system, which means that any transaction which you want to read or modify, you need to decrypt the transaction, understand how it is done, and then finally you have to read the transaction. If you see on the right side of the diagram, you would see that how it is being linked. The transaction has been arranged as a block, and these blocks are linked between. So that's why it is called a blockchain. It is a chain of infinite chain of transactions with additional data being added into the blocks. And if you see here, there are several other keywords which you would see often when you read about blockchain, which is the cryptocurrency. It is again, I would explain subsequent slides how this cryptocurrency works and how it is used in the blockchain. Right now, you should get to use the term cryptocurrency. And the DLT, which I mentioned, which distributed ledger technology, which is decentralized. And also certain properties which you should know is encrypted. It's always encrypted and hashed. Take a case of simple money transaction which you are doing in a blockchain. How blockchain helps you when you do a money transaction or send a money to someone. Think of a scenario you're using some provider to send a money, like PayPal or money transfer or any other transfer method to send the money from one region to another region. So what it happens is when you send some money, the update will not happen immediately. So it goes through different type of a party, then it goes to your commission, and you have to pay some amount of commission to the party. Then there is a change of currency takes place, and when there is a change of currency, there is also a commission takes place along the change of currency. So there are several processes involved in those money transfer. The blockchain addresses these kind of issues. The first issue which it tries to address is that whenever you do a transaction, the transaction will immediately be reflected into your ledger. It doesn't go through any of the third parties. And the second one, whenever you do the transaction, there is no middle layer of transaction happening. It directly goes to the ledger. And copy of a ledger is being available to anyone within your network. The blockchain is completely within your network, and anything happens, you get a copy of the transaction. So this is a typical scenario of sending a money. When you send a money, a transaction is being blocked into a block, and there is a block created in the network, and it is being published. You get a copy of it, which means that a transaction is valid. Then the original money is transferred into your wallet. Okay, so this is a typical transaction. Think of a scenario how the blockchain comes in. Okay, assume that there are 4 people involved in a transaction, or you want to have a transaction between 4 people. Assume a person A has $100 in his wallet. So a block of transaction which says that there is a credit of A to $100 which is being blocked. So it is thrown into the ledger. And think of like A is transferring a money to B of $25. So when he transfer a money, or a transaction is created and it is written into the ledger as a block. Okay. And another scenario where B is transferring a money of $50. This is again a transaction. This transaction is created as a block and sent into the network, and it is recorded as a transaction. Suddenly, A is trying to send a transaction saying that I am sending a $70 to C, which is an invalid transaction, because we already know that A has only $100 and he had already transferred 75 to B as well as to D. So invalid transaction of 70 automatically will be validated along with the previous transactions. How? That's how the mining comes in. So the miners, what they do is they validate the transaction against the previous transaction happening plus whatever the transaction happened in the blocks within the ledger, and they validate it, and finally they add the block into the ledger. So that's how these transactions are valid. So someone from the network is validating your transaction or transactions happening within the block. That's how the blockchain comes in. Not only that, previously in any technologies, they had all these transactions in a centralized place, so that, for example, if someone wants to check the transaction, they always need to go to the central location and find out whether the transaction has been happened. But in the blockchain technology, what happens is that each node, we call it as a node. In this scenario, we take a case of A, B, C, D. So all these nodes will have a copy of this transaction. So which means that any transaction which happens in your network, you have a copy already. So which means no one can tamper around it. You have a copy of it, you have a proof, which means I have a proof of it. A network B has a proof of it, A has a proof of it. So that's how the blockchain technology works in, and it becomes so confidential and trustworthy such a way that you cannot destroy the copy of a transaction, or you cannot tamper your transaction. Okay, so that's how the blockchain comes in, and also the distributed open ledger technology comes in here. The whole blockchain backbone is based on the open ledger technology. So that's how the blockchain has been built on. I have shown you how simple scenario where how the money transaction happens and the transaction being blocked. Okay, so later I would show you what is that data which is in the block and how does that block works. The first one is that blockchain is a decentralized ledger technology which has an asset in the network. It can be abstracted using the hash, and it can be linked. The transaction has been linked, and it is a distributed node. Anyone joins in a node will have a copy of it, so it is called a distributed node. So all your transaction, your blocks and everything has been distributed already in the network. And there is one more keyword which you should know when you are learning the blockchain, is that consensus. Consensus in a blockchain, or in simple term, in an English term on the consensus, is that a group of people who come and then agree on certain things. Like you have 10 people, they want to go for they are planning for a holiday, and each one would have their own ideas. But at one point, all the 10 has to agree on one consent saying that, okay, let's go to beach to have our vacation. So that's a kind of collaborative decision they are taking in. So in a blockchain, there are several ways this consensus works. Later I go through step by step what are those consensus. And finally, the trust versus non-trust, like whether you really trust the network to join in to do the mining, plus the blocks have been formed. So those trusts you'll have to manage in the blockchain. So these are the primary keywords you should understand when you start learning about the blockchain. The next thing I want to mention is that encryption. You the technology should have much been familiar than me. You have been often reading about these terms. Like whenever you want to send data from one network to another node, in a network of one node to the other node, you always have to encrypt your data. That's how the HTTPS protocol comes in. So any website, if you start sending a data, like HTTP is not secure. That's why they always have the HTTPS. What does that HTTPS? Meaning that it has a certificate for the particular site registered for the particular domain. So whenever you send a transaction, they would add their private and the public key, encrypt the data, and send it over across a network. So that in between, if someone tried to read the data over the network, it is encrypted. And finally, you cannot see the data unless you have your public key or the private key which you have. That's the same algorithm which follows here in the blockchain as well. Every transaction is created as a block. Each block is hashed and then encrypted. Hashing is different from encryption. There is a famous theory which is the Byzantine theory. So the Byzantine theory is nothing but how do you, Byzantine is one of the guy who tried to attack a city. So how do you coordinate multiple team within your combat network and then attack the city at a single point? That's how it tries to address the theory for him during the war. So the same concept, they try to solve it in the blockchain. It was done by Satoshi, who was the father of kind of a blockchain. So what they were trying to do is that whenever you form a message or a block in the blockchain, the message is hashed. Hashing is nothing but there is a certain number of text or the keyword which will be applied to a original message. For example, you are sending a message hello. The hello will not be sent as an hello. The hello will be hashed with certain keyword. There are several hashing algorithm in the computer network. So if you just go back and read about the hashing algorithm, they have so many of the hashing algorithm. What they do is they just take the original word, which is hello, and mask with these words so that if someone on the other side try to get the data and read it, it will be like a kind of a junk. Unless you have an algorithm on the other side saying that you dehash it, you should try to find out what is the message from. And again, whatever the message they try to send in, hashing and hashing on the other side trying to hash it, it will just tell you that the message sent over from A to the B is just valid. Nothing in between is tampered. And again, I'm repeating you, the hashing is nothing but it tells you the validity of the message. That's it. You cannot read the original message. It will just tell you at the other end saying that the message received from A is valid and it is received in the original condition the same way it is sent. That's it. So that is how it is hashing works. On top of the hashing, encryption works. Encryption is the one which will encrypt your data without making the other party not to decrypt and read the original hello message. So the hello message with encrypted with the private or the public key. So once it is encrypted, it becomes like a junk. You can see here, encrypted message. And if someone in the middle of the network tries to read the data, it will be kind of a junk. You cannot read unless you have a same public key which is generated for the private key and read the message, and finally you need to check the data. So that's how the encryption and the hashing works. It's a typical information sharing on the digital world. So coming back to the blocks, how these blocks are arranged and what is that inside the block. If you take a single block inside a blockchain, single block will have these three types of data. One is the original data. In the case of, say for example, Bitcoin network, this data would be like how much of the money you are transferring, plus who is the sender and who is the receiver. So three key data. This data depends on what type of transaction you do. If you are taking some other financial transaction, anything related to the financial transaction will be written in that. On top of the data, there will be a header, which is the hash, which I mentioned you, the hash header. And again, for in a block, the hash would have a previous block hash. Okay? So this is how it is linked. This is considered as one block, 2, 3. So all these blocks are linked, and when it is linked, each block would have a hash and the previous hash. And this block, previous hash is 0 because it is the starting of the block. So it will always be 0. We call this as a genesis block because it is a head of all the blockchain. So it is called genesis block. And more blocks are added. It is always serial. You will never see a fork or multiple blocks from that. It is always serial. And the second block will always have a previous hash of the first block. For example, see here the second block, it has the previous hash, which is the first block hash. Similarly, the third block will have the second block hash. Why? Because suddenly someone wants to tamper block 2. They cannot just tamper block 2. If they just tamper at block 2, the previous hash become like tampered. If this is tampered, then this is again tampered. So you will have to tamper from 3 to 1. So you'll have to keep on going on upper level until you reaches the genesis block, which is very, very tedious. That's why they say blockchain is kind of incorruptible or kind of very, very, very hard to destruct the ledger. So the blocks becomes much difficult to corrupt. So when a new transaction happens, for example, a new block is being written in the network. Remember, I told you before, there are multiple people in the network. Each one, they call it as a node in the network. So when a new block comes in, immediately a copy of the block is sent to all the nodes. That's how they make sure that the transaction is valid, authenticated, plus it has a copy on every side, so that everyone knows about it. Okay. This is a sample block of Ethereum. So if you see here, it is a Genesis block. It has a transaction. It has a digital signature encrypted and hashed, and it has a previous transaction hashing, and it has been linked. So this is how the typical block looks like in a Ethereum or in a Bitcoin. Okay, this hash will be a very long hash, which will be like a very long text. So in a simple word, sometimes why blockchain becomes very difficult to corrupt, or why they say it is indestructible. One of the lecturer which I had long back, he explained in a very simple term how the blockchain is very kind of authenticated. Is that, imagine you have a big you have a hall. Okay, there are 100 people in the hall, and suddenly someone, when you are in the hall, you are in one of the person in the hall, and there are 100 people in the hall. Suddenly one guy is coming to you and then giving you a gift to your hand, and then inside the gift there is a cookie. Okay, so basically he is giving you a gift of cookie. So think of like blockchain as the same. A transaction has happened in the open network. So this is the transaction. Someone gave you a cookie. That's it. If you really want to do the corruption of erase this transaction, so for example, if you really want to say that I didn't get any cookie from anyone, will it be possible? It's very difficult. The 100 people have seen that you have got a cookie. So how do you say that I didn't get a cookie? Nobody gave me a cookie. It is very difficult. So to make sure that you didn't get a cookie, what you should do, you should spend so much of amount, bribe each one who is in the hall, which is 100 people. You have to bribe 100 people in the hall, and then say that you have to erase the transaction saying that no, I didn't get the cookie, and all these 100 people have to agree to you saying that yes, he didn't get the cookie. To make sure 100 people to agree, you have to spend that money. So that's how the blockchain also works. If you really want to correct a blockchain, you have to be like a billionaire, so that you'll have to track back all the way to the Genesis node, which is really, really difficult. And you have to corrupt every block. So that's how there is some easy way to explain what is blockchain and why it is indestructible and not corruptible. So they make it open. Everything is, every ledger entry is open. So everyone has a copy. So you cannot just erase it. Okay. So that is a simple, very simple explanation you would get. And Ethereum, if you want to, this is more technical, so I would leave it to you. I mean, just a header, it has all the transaction detail and other stuff. It becomes more complex. So the next concept you really need to know about blockchain and the Bitcoin is that consensus and the mining. This is very, very important concept on the blockchain. Why Bitcoin become so popular in 2017 and 18 around the year, and it skyrocketed and everyone invested in. Later you would know about the mining and the consensus. So basically, you know how the blockchain works now and what are the transactions, what is that does. Why suddenly everyone started putting money in the Bitcoin and why it works. Okay, so let's deep into that. So later you would understand. So consensus and the mining. There are several types of consensus based on the blockchain technology which you are using in. Bitcoin and Ethereum uses the consensus method, which is called proof of work. In short, they call it as POW, proof of work. Proof of work very well works only for the open distributed ledger, which is for Bitcoin and the Ethereum. But it will not work for a private blockchain. For example, if you are running your own blockchain in your organization, proof of work will not work out. So they come up with different concept of consensus. Okay, so let me go to the proof of work, and then later I would explain you what are the other consensus. When it comes to the proof of work, there is a special concept which is called mining. What is mining? Why the whole world was into the mining during 3 to 4 years ago? It was like a buzzword for everyone. Everyone started buying their own machine and started mining. What is that? So remember I told you that each block is a kind of, every transaction is a block, and block has been arranged. But these blocks are not arranged by themselves. These blocks are arranged by the miner. So the miners are the people or the network or the node inside the network. These node will find out a block, check the block transaction, and then make sure that at what stage or under what block these block has to be arranged. That's how they do. That's about the mining. So basically they collect the blocks, check the authentication of the block, and then link it to the existing block. That's all. So they have to link it to the existing block. They will have to solve the cryptographic puzzle. This cryptographic puzzle is just an algorithm. That's it. So this is the general algorithm which is followed by Bitcoin. Bitcoin will have their own algorithm. Ethereum will have their own algorithm, and similarly, if they have any other blockchain framework, they have their own cryptographic puzzle algorithm. And Bitcoin was more popular because they have their own cryptographic puzzle. The miner would solve the puzzle, link it to the existing block. So that's how the mining takes place. But when you want to do the mining, let me go to the other, okay, let me come here and go back there. So when you are doing a mining, nothing but what it does is, you find a block, get the hash, and then get the previous block, and then try to match the hashing. So when you try to find the hashing, you keep on doing a brutal force algorithm. So we call it as a brutal force, which means that you keep on hitting the server and the node to find out a hash. That's it. So the hash, what it tells you is that your hash algorithm should match with the existing block or in the network block. That's it. So you keep on hitting multiple times. When you find the exact hash, you find it that this is the block which I need to add under. That's it. So it will all be kind of a computation. That's it. There will be a algorithm fabricated into your network. You just call the algorithm. It would use your computation power and your CPU, your network speed, everything. It depends on all those. So that's why during 2017 or 4 or 5 years back, people were selling mining machine. The mining machine, nothing but what it does is, mining machine built in will have an algorithm built in, the cryptographic algorithm, and it will have a very good network speed. It will have a very good network speed. I think, let me resume my presentation. Someone presented it, okay. So the mining, this machine will have a very good network speed, plus it will be a very powerful machine to run. The CPU computation will be more, so that your hashing algorithm will be running so fast. Why they were doing it? Because whenever you identify a new block, which is, whenever you identify a block and make sure that the block is valid, then you get a reward for the block. Okay. So the reward for the block will be kind of a Bitcoin. So for example, this hashing algorithm, they would include at the last character 10. Imagine you do a 10 at the last character. This 0 is decided by the Bitcoin network, not by you. The Bitcoin network will decide as at the end it has to be 0. So what it does is, your machine, the mining machine, will keep on hitting the server and then try to find at which algorithm the hashing becomes 0 at the last. So it will run for, probably if it is 10, it takes 10 minutes. So in a network, assume in a roughly around sometime 10 minutes it would take to find out that trailing 10. If too many people join to the network, suddenly the Bitcoin network will auto calibrate and then will add one more zero. Adding a 2 0 in your hashing, it will increase your mining speed. I mean, the mining delay would be around half an hour, or it may go to 1 hour. If they add one more zero, then it becomes like 2 days or 3 days. If they add one more zero, it becomes like months. Okay, so they can calibrate that mining speed plus the nonce based on the nonce. They call it as a nonce. This term, which is nonce, this is the zero. That's it. So if there are no node in the network, they will just use 1 0 for hashing. So you'll just find out in 10 minutes. If there are more people joining, they add more and more zeros. So your life becomes very difficult. You have to spend that much of a CPU, your current, your electricity to get one Bitcoin. So that's how it is. Initially, when people doesn't know much about the Bitcoin, they got the Bitcoin in just 10 minutes or 20 minutes because no one in the network. Once it becomes so popular and everyone started mining, it will take 1 month to get one Bitcoin. So 1 month of your electricity is gone. 1 month of your computation you should do in your network. So for that, people started investing more, adding more and more small machine that does have more CPU, less cost. Then they add a cooling machine. So all these, they started doing more. Some people, they even went so crazy that they did the whole, they created the whole data center, partition each floor for mining, and they sold the floor, which means that I want to become a miner. I can just spend $10 a month to that company. The company will mine for you, and when they get the Bitcoin, you just share. So it becomes so crazy at that level. Okay, so this is called mining. This is called, and all these runs under proof of work. Okay, so that's how the proof of work works. So now you should have an idea about the proof of work. And regarding the consensus, there are several other consensus you should know of. Proof of work is used by Bitcoin and Ethereum, and there is one proof of stake. Proof of stake is nothing but once you become a very reliable person in the network to mine. For example, I'm doing a mining for almost 1 year or 2 years. Then my position might be upgraded such a way that any block I find, mine will be given a more priority than the newcomer. Then it becomes like a stake. I take a stake of it, and then I become a much more advanced guy than the novice. There is one delegated POS, which means I delegate someone to take a control of the POW, and I would do that. So this POS and the DPOS becomes more popular. Then later, they started hacking that as well. Like 1 month I've been doing mining, I become more popular guy. So any block comes to me, I get the more priority. I get more Bitcoin than the other guy. So it becomes more kind of popular. Then the final one, I mean, not the final one, there are several other. The other one which is more popular is the proof of authority. Proof of authority is more widely used within the enterprise. Nowadays, in a banking domain or in a financial domain, they have their own private blockchain within different, to tie up between different banks or to tie up within different financial organizations. So for that, proof of authority works out very well. Imagine you are, take a case of like SBI Bank. Think like the SBI Bank is implementing blockchain technology. So to arrange your transaction or your block, can we put SBI Bank to trust on PWO, which is the proof of work, which is impossible, right? If you are doing a transaction, money transaction, someone would be mining your transaction and make sure that it is valid and it is added into the block. How long you'll have to wait for that to happen? It is impossible. So that way there is a separate concept of POA, which means based on the authority. It is a typical enterprise workflow scenario. If your transaction has to go through several layers, people who approve the transaction will approve, and it goes to your manager, then subsequent manager, and the finance minister, finance authority people. Then it goes to the verification, and it goes there. So it all based on your organizational authority level. If you are a CTO has to be approved, then your transaction has to be approved by CTO. Then it goes to multiple levels. So the POA is mainly for the private blockchain. And this is proof of work. So whenever you do the mining and arrange a block, there might be a situation where it comes to a forking. So forking is nothing but suddenly the node from one person had found out a block valid. Similarly, another node find out the same block as a valid. So both cannot insert at the same block. So what they do is they insert, they come into a consensus saying that there will be a delay time of six blocks of 60 minutes, so that you have to wait. The one who comes at the first will take over, the other one has to wait. Then you'll have to remine and then add it to the block. There will be at any point, there will not be any forking, which means that all the blockchains are serial, just one by one, that's it. There is no tree. So this will be arranged, always serial. So next comes the blockchain framework. This one becomes more technical, like what are the frameworks available in the market, how do you program it, why you want to do a blockchain programming, that's again one question. First thing is that blockchain technologies, when it comes to the release, mostly it was used in Ethereum. Ethereum is one of the platform. Why Ethereum? They inherited the Bitcoin blockchain technology, and they came up with the concept of cryptocurrency. Okay, so cryptocurrency is nothing but what happens is that it's like your Apple Store. So, for example, you develop an application, upload into the App Store for anyone to buy the app into your iPhone for you to pay. So same concept. Ethereum comes up with the same concept. Like you develop an app into the Ethereum platform and publish it. Anyone who comes into the network, they should have a wallet, like a Apple wallet. They should have a Ethereum wallet or open wallet. And whenever you buy the app, based on the app inside what it does, you will get a Bitcoin or the Ethereum or a token on Ethereum platform. So this token is nothing but, this token is not directly the money. They always give you a token of their own standard. For example, it is same as you entering into a theme park. So suddenly, if you are looking in certain theme park, if you enter in, they will give you some token. It is not directly related to your money, but with that token, you can buy a drink, you can buy popcorn or something when you enter into the theme park. So that token is valid only for that theme park. When you come out of that theme park, that is just a paper. So same concept. So within an Ethereum network, many people started creating their own token. Okay, so these tokens are similar to kind of it has some value, like depends on the token. There was a Golem network, GNT. So what happens is that GNT has a token. So whenever you share your system, they give you some token. 10 GNT token might be equivalent to 1 Bitcoin. So 1 Bitcoin is equivalent to some $9,000, $10,000. So it is like you should convert into something, some other token to make it usable. So everyone started having their own token and match that token to a value of money. And the value of a token depends on the demand. It is a typical financial or the marketing strategy. Like the more people you want a token, it becomes the more value. That's it. So similarly, that concept has become more popular during those days when Ethereum was there. I was one of the Ethereum developer. I tried to develop some of the app, but I could not deploy that. By the time it was like market was almost down and no one wants to have the Ethereum kind of. So at that time, there was funny applications like the crypto puppies, crypto doggies. There are so many applications like crypto doggies was very famous, very popular. What one guy has created is that he created a dog, okay, just a dog with a digital look of a dog. It looks very ugly as well. It is just a
Me
digital
and Papri,
dog.
we used
When
to
you buy
put
the dog,
in
you
YouTube
can
in a
uh,
very professional way.
buy multiple dog.
I mean the
Like
video
you
lectures
got a
and all.
blue dog, you
I
got
have
a yellow
given the
dog.
link also.
You can merge and
It's
then
in,
create another dog
if you
and
like
sell
it,
that dog.
then
So people are so
since you are
crazy,
staying for
like
hours
crypto
now,
puppies, crypto dogs.
sir,
It becomes so
I
crazy.
don't think
People
she will
started
be able to
creating
come
unique
during
colors.
that time
The one
because
who
it is
has
the
a
last
unique
stage.
puppy,
So
he can
that
sell it
also I
for
will discuss with
one
some
Bitcoin or
other
two
time.
Bitcoin.
Okay.
People were really crazy and
Thanks.
they were buying as well.
And
Some are
we need your blessings,
started
sir.
fighting that I want that
We
pink
all
dog.
are
How do you
practical
create that
because
pink dog? To
we
create
are
a pink
actually
dog, you
there
have to buy all this
because
or
now
you buy
the
directly from
condition
me.
in
So it becomes so crazy.
hospitals are not allowing
That
us.
has one of the
Hospital is not
application
that
which was there.
small hospital.
And there
Is
was a golem
actually,
network. So
sir,
later I
it
would
is
show
not
you.
in our hand. Doctor,
Okay,
when
let
where the
me go
doctor will
back
do, only in
here.
that nursing home I have to go.
I show you what is that.
Okay, sir, we'll keep in touch. No, thanks.
Okay, the app token. So this is the token. Let me finish this, then I go there. So that's why the Ethereum started coming up. Why the Ethereum was, you can create an app and then publish it and you can have your own token. So that's how the Ethereum started becoming more popular than the Bitcoin. To create your own token and your own application, there is one more concept which is called the smart contract. So if you see here, if you want to become a the blockchain developer, you should know about smart contract. Smart contract is nothing but if you are doing a C++ programming or C programming, smart contract is nothing but a group of functions set under a class. That's it. A group of function which is into the class. A smart contract, you create a smart contract using any of the languages and publish it into Ethereum. Then anyone who is calling that smart contract will invoke it like transaction of a money. So whenever any person in the network invokes this smart contract, your own smart contract, you get a commission out of it. So you use a token. For example, you are sending a token from one wallet to another wallet. You get a commission of 0.01 some value. It's set up to your application. So you will get some commission. That commission finally translated into a token. Then the token is translated into a value. So that's how the Ethereum works. So this is the nomination for the Ethereum. They call it as Ether, and the minimum is the Wei. Wei is one of the nomination. How they calculate this Wei, and then any of the nomination comes in blockchain, it all boils down to the computation power of a CPU. In Ethereum, it is called Wei. In blockchain, Bitcoin, it might be a different term. In other blockchain framework, it will be a different term. But there is one valuation tied to your computation. Why? Because you have to pay to someone who is running in the network, right? In a cloud. Nothing comes for free. So this Ethereum or Ether nomination is related to your computational, the CPU computation number of hours or the number of minutes it is running. If your CPU is running for 1 hour for a particular operation and an operation is done, for example, sending a money, writing a transaction into a ledger, this is one operation. To write an transaction into the ledger, if it takes 1 minute of a CPU, example, it will not take 1 minute, just 1 minute of a CPU time. Then that 1 minute of a CPU time is translated into Ether, which is Wei. And that amount is charged to your network or the node. Then that is translated into a token, then finally it merges into a wallet. So that's how the aggregation is. So that's how the whole machine in the network runs. The token which I mentioned you, it is similar to the one which they give it in the cinema ticket. So it's like a cinema ticket. For $50, you are getting a ticket, and this ticket is only for that cinema. You cannot just take that into another cinema. They'll just throw it as a paper. But actual value it is $50. So that's how the token works. And DApp is the app which you develop in the Ethereum, and it has its own token. They have a usage token and worker token. This is kind of too much of a technical one, but basically they have a different type of token inside your system. This is a typical program which you write inside a smart contract. Like when you are sending a coin, you just transfer it, the source. So it's a typical C program you should write in a smart contract. This is called smart contract. You would write, this applies for both Bitcoin as well as the Ethereum. But for the other framework, it will vary. Okay? There are, during that time, there are so many popular decentralized apps. We call it as a D app, which was more popular, like Storage, Steam, Augur. These are all the very popular application which was on the network. How certain things work is that, like take a case of the Storage. Currently in each one would have their desktop in the home. So what they do is, you just have a desktop, you have 1 TB of memory, and you have i7 processor running, and you have a monitor. Think of like, will you be really using the full i7 processor speed? No. Will you be using all that 1 TB of memory? No. So they come up with a concept of storage. What it does is, you out of that 1 TB, you can share 500 MB or 500 GB of a space to the public network. That's it. So anyone using anywhere in the world, they can start using your storage network. That's it. You are just sharing to anyone who doesn't know in the network. It's just that you trust the storage, which is a centralized application. They would take care of using your storage. So for giving up that 500 GB of storage to someone in the network, you will be paid with storage token. This storage token will be again translated into a Bitcoin or some value. Say for example, if the usage is more in your data storage, you will be paid more. So in a week, you get number of read and write, you will be paid. So a decentralized business model start emerging. Similarly for Golem network. So GNT network is very famous, GNT token, which is a Golem network. This became very famous because company like NASA, what they started doing is that they get so many high resolution pictures, but to process the resolution pictures, they cannot be keep on adding more and more CPUs. So what they come up with a concept called CPU dedicated. So I told you the same situation. You have a i7 processor desktop machine in your home. You're not using it most of the time. So what you can do is you can connect with the GNT and then say that I dedicate some of my CPU power to online. That's it. So the NASA, not just the NASA or anyone who wants the CPU usage, they will tie up with Golem network and they get the CPU. For using your CPU, you will be paid with Golem network time, Golem network token. So you'll be given a GNT. One GNT might be equivalent to some 0.00001 Bitcoin. So similarly, you started earning just by doing nothing. You just sign up to the GNT, give your CPU. That's it. Okay, this becomes more easier. So the decentralized business model become more and more popular with blockchain. So this is the concept which I mentioned. You can read later. Okay, and the next one comes about is the public and the private blockchain. There is a concept of public and the private. Bitcoin, Ethereum are all public, and you can run your own blockchain in your organization. That is called private. And the consensus method, it's up to you. POW is based on Ethereum, but if you're running some other blockchain framework like Coda is very famous, as Nagaraj sir had mentioned. IBM is a very big contributor for Coda. Coda is especially used in all the financial domain. Most of the financial domain, they use Coda framework because it is built for finance with approval framework, all the compliances, policies, everything is built in. Okay, and private network, it's up to you. You deploy your network, you decide what to do with that. Okay, and you can have a full control. But the public, it's always hashed and it's completely encrypted. Private, you decide how to be hashed and encrypted. You can even run it without hashing. And development options. If you want to be a developer, Ethereum nowadays no one does. So you can use simple tools, Visual Studio Code, and then you can start using Node.js. They have so many of the frameworks. Programming language is already, let me, Ethereum nowadays no one uses. Okay, so finally, blockchain service. So blockchain has matured. Initially, when blockchain was releasing, everyone was having their own scattered framework, started investigating which one is good, what is that to provide. Each cloud provider, like the Google network or the AWS or the Microsoft, they started having their own blockchain as a service. So one of the blockchain as a service which Microsoft, this is from Azure, Microsoft, which they provide is that they have their own blockchain framework. They tie to your existing enterprise network. So from Azure, you can immediately spawn up a blockchain up to their own network. For example, if you want an Ethereum network in your own company, you can spin up 2-3 Azure machine. Automatically, it will create an Ethereum, completely everything done, set up in just 20 or 15 minutes. Say, for example, you want Coda in your enterprise. You just click, just by 2-3 clicks, it will create completely the whole Coda setup. You don't have to worry about which machine to provide all those stuff. Finally, it will just create the whole blockchain framework ready to be done. It will also create one Genesis node and then Genesis block, and it will be ready. What is the major advantage? If in your organization, if you already have your IoT machines, your document management server like the SharePoint or any document management within your network, you have already your SQL server or any of your backend system, everything will integrate with your blockchain. So blockchain you can use just as your financial integrity solution. Behind that, any document related to the blockchain of a transaction. For example, a transaction is happening, you want to attach a PDF. Then the PDF goes to SharePoint, the transaction goes to blockchain. So that kind of a setup you can do now with Azure blockchain as a service. Okay. So now most of the other areas also have been integrated, like IoT. Imagine you are doing a business, IoT business, supply chain management in an IoT. So the IoT data, all data, it can go to SQL server or your Azure storage. And the main transaction, it goes to blockchain for validity. And you can even have your mobile apps developed, integrate to blockchain. It becomes much easier. You don't have to worry about how many servers I have to spin up, so all those stuff. Okay. So that's how the blockchain as a service component which you can see. That's all from my side. Any questions, you can just post it in the chat.